Good morning. I'm really excited to be back speaking at Multiplai. As you guys know, this conference is Target's love letter to the retail applied data science community in Bengaluru. And today, I'm gonna offer up some of my own thoughts on an emerging discipline in the applied data science and product engineering space at Target, that of token operations. Now, for many years, Target's been building applications with LLM features at the core of the experience. And recently, agentic workflows have started to go mainstream in some of our most important line of business applications. And there have been lots of lessons learned along that journey. Today, I'm gonna talk about a specific set of lessons, though, that we've learned when building agentic systems that are customer-facing, when the scale of the interactions with the large language model number in the billions. This talk is about the economic architecture that has to be put in place alongside the technical architecture to make sure that the agentic experience is not only great for the customer, which we refer to as guests, but it's also affordable for the retailer. So building on an open-ended agentic experience where the demand for the application and usage is extremely large and difficult to forecast, doing that with anything other than ruthless engineering efficiency can produce an economic calamity for the retailer. So today, we don't want any economic calamities, so you're gonna hear about how we've reduced the operating cost on our agentic shopping assistant that we're building for Target.com and our mobile flagship application. It requires a mindset that I call sweating every token, but it also relies on clever engineering applied to LLM interactions. All right, before I begin, I want to tell a little bit of a story. It's a personal story. I recently went on a backpacking trip for 5 days in the mountains of Southern California with my teenage son. We put everything for our camping trip on our backs. I'm an experienced trekker, but this was the first time that my teenage son had done this kind of a trip before. And so we were going to do some training hikes. And so I encouraged him to pack for the training hikes exactly like he was gonna pack for the expedition. He brought his pack out to the car for the first training hike, and it was as if he had crammed his entire bedroom and half of our garage into the pack. He only weighs 50 kilos, but the pack weighed 25 kilos, right? So I could very quickly see that the weight of the pack threatened to totally derail the experience. Now, the reason I mention that is because architects of complex agentic systems have to think about the weight of their system prompts, just like trekkers think about the weight of their pack. Trekkers talk about sweating the grams. Why take an entire toothbrush when you can snap off the handle and take half a toothbrush? In agentic systems, you also have to sweat the tokens. Every single token matters. Token consumption used to be a useful sign of adoption. But once AI-enabled features became prominent into guest-facing applications, volume makes the token costs highly visible. Verbosity becomes not only an architecture, but also an operating cost concern. In AI systems, the system weight, or the weight, shows up in your tool schemas, in your policies, in your system context, your retrieval results, your reasoning, and your output. These are not abstract technical concepts. They literally determine the cost, the speed, and the quality of your AI system. So different journeys should carry different loads. Is this particular turn with an LLM the equivalent of a 5-day trek in the mountains, or is it a 2-kilometer walk in the park? The Target team recently went through a significant token optimization effort in preparation for the beta release of our agentic on-platform shopping assistant. This shopping assistant is gonna allow our guests through natural conversation to be able to browse, research, and transact on Target.com or in our flagship mobile app. And industry data suggests that the American consumer increasingly favors conversational commerce. And we also know that it converts at a higher rate than traditional commerce. And so it can be really appealing for the retailers, but only if the token economics can be properly managed. LLM interactions lie at the heart of the experience, and a tiny per turn number can sound quite harmless. That doesn't look so bad. But at the traffic scale of our holiday season, tiny becomes material. Early ballpark estimates on usage and cost showed that we had a lot of room for improvement. This is not acceptable. The monthly cost does not come down to like one bad prompt. Instead, it comes from small inefficiencies that are repeated across massive traffic. Now, profit margins obviously in e-commerce are small, so every single ounce of weight in the pack further erodes the profit margin. My challenge to the team was reduce the token consumption without sacrificing the guest experience, and thus began my own education. The team wanted to know, are we talking about input tokens, output tokens, or rag stage tokens? Or maybe context token, completion tokens, or multimodal tokens? Or possibly, Brad, it's embedding tokens, fine-tuning tokens, reasoning tokens, or function call tokens. Or maybe we should just look at the overflow tokens, the streaming tokens, and the system tokens. The details matter. All tokens aren't created equal, and you don't even get billed for all of these tokens from the token providers. But it's important not to think of tokens as the only operating weight. It's not just input and output. The weight includes context, tool schemas, tool results, reasoning, rag stage work, embeddings, multimodal payloads, and a lot more. This picture on the right here, this is what version 1 of Shopping Assistant was like. Full prompts, full policies, every tool, all raw history, broad product context, and a large model everywhere. The backpack here is not the user request. Instead, it is the payload that we send into the model path. Token operation starts by asking, what can the architecture leave behind? The problem to solve for the team was, every single guest journey in Shopping Assistant is by its very nature unique. But the naive architecture packs for the hardest one every single time. At this scale, with tens of millions of future guests using Shopping Assistant, inefficiency will make the experience economically unviable. So, the team got serious about packing discipline. And I've grouped our lessons learned into 4 levers that can lighten the load. And we're going to discuss each one of these. Avoid the call, shrink the payload, trim the fixed overhead, and change the economics with tactics in each one. All right, the first question, in some ways, is the most fundamental. Should we call the model at all? Deterministic flow means that we use code, we use rules, services, templates, filters, or validators when reasoning is not required. Not every guest interaction on Shopping Assistant is a reasoning problem. Some interactions are exact lookups or eligibility checks, and those are better handled by enterprise application systems than asking the model to infer. For example, if a guest asks whether or not an item is eligible for pickup at its store, the source of truth for that is the inventory system. Okay? The LLM does not need to reason about this. And the architecture can call the inventory service, it can validate the results, and it can return a grounded answer. This reduces token burn, but it also improves quality and safety because the deterministic systems do not hallucinate. They either have the data or they don't. And it's not just a cost tactic either. It's also a reliability tactic. If Target already has the answer to that question in a structured system, then don't make the model recreate it. Pre-model intercept. This catches the request before the full prompt is assembled. Why is this useful? It's useful because sometimes we're going to have non-shopping conversations in the Shopping Assistant, or unsupported or unsafe interactions. What if the guest asks us for the betting odds on World Cup soccer matches? Instead of building a full Shopping Assistant prompt, retrieving all the tools, loading the product context, instead the architecture can intercept that, and it can respond through a very lightweight path. In the backpack metaphor, this is the equivalent of taking a stroll through your neighborhood or a stroll on your lunch break. No pack is required at all. The cheapest token is the one that we never send. All right, but now once we know that a model call is actually needed, the next question becomes, what is the smallest useful payload that we can send? All right, now we're in a different situation. We have decided that the request definitely needs the model because maybe the guest needs some help comparing products, it needs a recommendation, or interpreting feature trade-offs on the products that it's looking at. But even then, we want to send the smallest useful payload possible. Maybe the current request, the relevant state, the right product evaluation, and we are going to insist on a bounded response. This is where we move from avoiding the call to shrinking the payload. In backpack terms, we're only packing for what the trek actually requires. All right, this category has 4 tactics. Lean invocation is the first one. The model call only carries the current ask and the minimum required state. The naive pattern is to append the entire conversation history, every prior assistant response, and all possible contextual information. But the better pattern is to maintain a compact session state. For example, in our parlance, it would be the selected store, the preferred fulfillment method, maybe budget or dietary restrictions. The model does not need the full transcript history if a concise state summary will suffice. Now this matters because conversation history can quietly become a major token expense. Every turn gets heavier and heavier if you're resending all of the raw history. Field projection. This means that we trim product, price, inventory, seller, and policy, all of that data down to only the fields that matter for that particular ask in that particular turn. So product data, take for it as an example. Product data is one of the biggest sources of prompt weight for a retailer. Our item catalog for every single item is hundreds of columns wide. So, and also on a Target.com product page, you've got all sorts of information on that page. You could have bullets, specifications, warranty information, promotions, etc. So most requests, though, in Shopping Assistant only require a subset of that. So sending just the subset not only improves cost and latency, but it also improves the quality of the response because the model is less likely to get confused and distracted by irrelevant details when the evidence is shaped around the decision that the customer is trying to make in that particular shopping journey. Compact encoding is the next layer. After selecting the right field, we represent it in a very compact and structured way. So instead of sending paragraphs of product descriptions, we send terse product cards, very structured data. The model can still reason over the facts, but instead of sending the long paragraph maybe about the blender that the guest is asking about, you send something that is much shorter, like the product ID, the price, the capacity, maybe the motor size, something like that. That's enough for the comparison without carrying all of the marketing copy in your prompt. Reference output. Reference output means that the model, when it returns the answer to you, doesn't need to copy the full product details back into the answer. The LLM should be instructed through your prompt to return a compact semantic response. Maybe it has product IDs, short reason codes, some caveats, etc., and maybe a confidence level. The app or the UI layer is the one that renders the entire product card then for the guest. This is a major design principle that you need to pay attention to. The LLM generates the guest-friendly explanation, but the application creates the entire shopping experience. This saves on output tokens, and output tokens matter a lot because they're very, very expensive. It also reduces risk because the product truth stays rooted in our own systems rather than being rewritten by the model. So, how's our pack looking? We've decided not to take the entirety of our bedroom and our kitchen. The items we are taking, we've put into compression sacks so that they fit nicely into our pack, distributes the weight of the pack. Now, let's look at trimming the overhead. So once we've shrunk the dynamic payload, we still have another kind of weight that we have to manage, which is the fixed overhead that we pay on every single turn. Fixed overhead is the stuff that shows up over and over again. It's your system instructions, it's the tool definitions, it's your policy language, your schema, your safety information. This overhead becomes the default weight every request carries. Scoped tools means that we only expose the tools that are relevant to that route. So a shopping assistant, which is an application that can do a lot of different things, it has access to lots of tools: search, product details, inventory, pricing, promotions, etc. The naive pattern is to expose all of those tools every single time, but that creates tool sprawl. The model has to read more definitions, it has to choose among more options, and potentially make unnecessary tool calls. The better pattern is to do route-specific tool exposure, clever engineering. This removes tool schema tokens and it reduces the reasoning burden. Think of this as only packing the gear for the kinds of trek that you're going to do. Do not take the pickaxe if you're not going to be scaling glaciers. Dense system prompt means that the stable instructions are concise, they are high signal, and they are cacheable. And that last word matters a lot, cacheable. In early prototypes of any application, it is very common for the system prompt to grow organically because every new concern that business partners has gets added as another paragraph in the system prompt. Brand voice, safety, product truth, disclaimers, fallback behavior, tool use, etc. While the stable prompt should establish the durable invariants. Use only established product data. Do not invent claims. Respect guest constraints. Keep the response concise. Use the structured response. These detail context-specific guidance, it shouldn't all live in the core prompt. That's what policy cards are for, what validators are for, what route-specific controls are for. When you do this, it also supports prompt caching. Stable content can be reused more efficiently and more often if if everything stays stable and the dynamic prompt comes later. The more that a model provider can cache, the less it will charge you for tokens. All right, policy as skills is the next tactic. It's one of the most important tactics for a guest-facing shopping assistant. The bad pattern is sending the full responsible AI policy corpus with every system prompt. That's expensive, it's slow, and it's not necessarily safer because the model has to interpret a large amount of policy text that may not be relevant to the current request. So the better pattern is to instead detect the risk domain with some clever engineering and send only the applicable compact policy card that's relevant to that part of the RAI policy. It doesn't, if you're doing a product comparison on a blender, you don't have to send the entire full dietary, allergen, child safety, sustainability parts of your RAI policy. So trimming fixed overhead means that the assistant stops paying the same setup cost for every single journey. The size and weight of the pack is appropriate, and we're not taking the pickaxe when we're doing a 2-kilometer walk through the rainforest. All right, the last category is changing the economics of the call itself. Right size model, this one is self-explanatory. It means that we match the model to the difficulty, the risk, and the latency needs of the request. At enterprise scale, using a single high-end model everywhere, it's not economically feasible. It's not economically responsible. Many tasks do not need frontier model cognition. So things like intent classification, typo detection, simple availability answers, those can be handled by smaller models, deterministic services, or templates. More complex recommendations, comparisons, high risk or policy sensitive requests, those should use a higher model, but selectively. For the shopping assistant, the target pattern is a route ladder. You do no LLM where possible. You do small models for simple or bounded subtasks. You do mid-tier models for recommendations, and then you do stronger models for the high-risk or complex situations. And then open weight option. The idea here is that some bounded internal subtasks may actually be candidates for a self-hosted model. But open weight, while it does change the economics, open weight doesn't mean free. It changes the cost structure, so instead of paying like a per token fee from a provider, now you're gonna have to factor in things like GPU infrastructure, latency tuning, monitoring, incident response. Those things are not free, there's a cost associated with them. So the discipline posture is to use open weight models behind the router for bounded subtasks, but only after they pass the same evaluation suite as your hosted model options. These 4 jobs become real in the guest journey. So we're gonna walk through 4 conversations with the shopping assistant to see how these tactics played out by our engineers. In this one, you can see that we have a real shopping task. It's a simple question, but it's a fact lookup. The architecture should not carry the entire catalog or reasoning loop. What comes out of the pack? Irrelevant tools, extra product fields, oversized model choice, and long response. It scopes to the inventory, shows only the product and the store availability, and it returns a short, grounded answer. Second conversation. Now we're doing some product comparison. Now the model has to reason, but the pack still stays focused. We're not asking for broad discovery here. What comes out of the pack is a broad search, full product pages, raw product data, and verbose product copy. The architecture carries limited product references and just references to the relevant products displayed here. Compact encoding and reference-only output is the reasoning useful. It makes the reasoning useful without copying the entire product catalog. All right, the third one. This is the heaviest guest journey, and that's okay. It has recipient, interest, budget, fulfillment types, and family safety constraints. But we can still be clever here. What comes out of the pack is the full policy binder, don't need that, an unbounded search loop, unsafe candidates, and a long 20-item list. The architecture retrieves only the relevant policy skill, it applies the validators, it narrows the candidates, and it caps the loop. And it returns a bounded product reference. The guest did not ask for a whole bunch of options, and so the architecture has to honor that request. All right, and then the last one. This one's a bit silly, but we're going to encounter this in production. For this turn, the best optimization is not a smaller prompt. This request is outside of the shopping journey, and so the architecture should avoid building the full shopping payload. What comes out of the pack? Product context, tool catalog, model loop. Again, the cheapest token is the one that you never send. Every application that interacts with an LLM faces the law of triple constraints: the quality of the output, the cost of the tokens, and the speed of the response. These all play against each other. Token operations is not about minimizing tokens at all costs. If we strip out too much, the experience for the guest will suffer. If we keep too much in, then the response gets slower and more expensive. So the discipline is knowing what the journey needs and packing for that balance only. The cost here is how heavy the backpack is, the speed is the path, and the quality is the view from the mountain. And the right answer today is not going to be the right answer forever. Things will change, models will change, pricing will change, safety requirements will change, guest expectations will change. That's why token operations is not a one-time purge. It is an emerging muscle for product engineers and data scientists. You instrument every turn, you learn where the payload is coming from, you tune the architecture, and then you rebalance. This is the next generation of economically intelligent architecture. Winning is not about interacting with the latest or the most advanced models. It's not about having the most robust system prompt, and it's not about having the biggest context window. Winning is knowing what to carry, what to leave behind, and when to spend tokens because the experience deserves it. The next generation of systems, of AI systems, will be economically intelligent systems, and the goal is value per token. Thank you very much.